Hello and welcome back to another session of serde-yaml. It's Byron speaking. In the previous session we have added plenty of tests for the upcoming mapping implementation. Not that I have planned to get mapping in here right away, just because we are not yet done with the sequence handling, but sequences kind of forced me to get some more details about how this would look like with the null handling and stuff, because null may not be hidden in flow sequences, but may be hidden in in flow mappings, even though with the addition that we force anything that is contained in a flow structure to be flow as well. So in this case, our mapping would be expected to be a block mapping because that's the default for YAML, but it can't be because it's contained in a flow sequence. Yeah, I think I might as well add some more tests here, and all this should be working similarly in flow mode. So I can just change this around here and say, well, opts mapping details style should be structure style block flow. And now we can expect flow mode, which looks like this. Yes, there is a space. And then we have what would we have? How's the comma implemented again? How's this handled with sequence flow? Comma space. Yeah, I'm not so sure about the comma space here, even though I think by default we don't put a space there. Don't know. Also, I wonder, is it possible to not have a space here? A comma here? No. Comma is required. Okay. So anyway, let's change this. Right now we have no new lines anywhere here, so these can go away. And all I can imagine is that we have a comma right here and a space here. This is what I would expect. And then for beautiness, for prettiness, we have a space here, which kind of comes with our implementation here of the close function or close method. Okay, same thing here. Here we would expect a space, then this, then a comma, space, this and that. Okay. Same again. Instead of a new line, we have a space here, comma, space. And here we have a new line, but just a new line. Oh no, wait. Space, and now we have a new line. Like this. All right. So now we shall show the nulls. Space. Yeah. Comma. Now this looks better. Key 2. Yeah. Like this. New line. Blah. Okay, that looks good. So if we hide all null values, then obviously now it makes sense, right? Even though we would expect no new line here, and here we do expect a new line. And if we have one value that is set, then we would expect something like this and that. Okay, so that should be what I would expect from the rules we have now. And that's all the tests I can imagine here, because it involves document start and end and involves no line break. So at some point we probably want to add some line break testing there as well. But right now we don't have it. We don't have control over the line break at all, except for where we have no choice. Okay. I think I could commit this just because we basically added. Gee. Maybe this is faster to run. It is. So I implemented the mapping flow test. Tests, sir, mapping flow test, impl. It's derived from block flow and will need quite some work until it has a chance to succeed. But yeah, one thing after the other. This is skip CI because it obviously doesn't work. From now on, most of the commits might be skip CI because we have 3 tests that fail now and some work to be done. Okay, let's take the easiest test that there is and that fails. Mapping block. Mapping block. All I want is a key, and basically open needs to be implemented, right? So if we are in mapping mode, then we want the mapping details style. What else is there for the mapping details? Mapping details. And we can just have a look at the JSON, the YAML standard. Block mode, explicit tag. Explicit entries. This is relevant. Oh man, this is, yeah, for open it's not relevant at all. Let's just see what we have here. For open, this is not relevant. For open, the only thing that's important is is this. So what happens? Key value. Okay, good. So that really wants a new line. Same with the way sequences are handled. So I think we could do the very same here. Basically. Yeah, I see no difference really. So if you're in block mode and it's an empty document, then there is no new line necessary. If you're in flow mode, you know, there's this special handling basically that makes sure we get a space where we need it, if we need it. I think that pretty much looks the same, except that we want to look at the mapping details style instead, and that is the same. And in flow mode, it's really just that. We could consider simplifying this, because all we really are interested, I mean, let's see if that kind of works. The close we have already implemented, fortunately. And for now, oh no, wait, here, look at that. That's the difference. This is the stuff we don't do. So yeah, I was thinking about kind of unifying this because these branches are very similar to the point where only this character is different, and it's something we can easily abstract on. But as long as we do not know how to deal with this push and what data we want to keep, you know, we will not optimize this. So we will consider a refactoring run. Review st, consider merging these branches. They look similar. Have to wait until internal data structures stabilize. I think that's really the problem here. But anyway, that's the thing. Let's see how far we get. It shouldn't panic anymore. Now it should panic elsewhere. Huh. Okay, so mapping block. Key. Okay, there something happens. That's not too bad. Except for the fact that we don't handle the keys correctly. So I think now we have to look at the key implementation. Do we have this? And a map element. So how does it work? This might be the thing that is called here map element. So we go with the separator, yeah. And then, so here comes the colon, key serialized self. Okay, so key is serializable. And key serialized self, what's being called there? I think the key really is the kind of value that we get here. Oh. And there are various things that we have to think about. So if it's a scalar key, so what's called here? I think this thing now needs to know that we are managing a key. Oh my. So for instance, if we are visiting a U64. Oh wait. What happens if, what's called here? What if the key in JSON would be What if the key in JSON would be an integer? Then according to this, it wouldn't even do anything with that. I mean, it just would throw down the integer, which is invalid, right? It wouldn't have enclosed indicators. That's what I'm saying. Yeah, damn. So I think the way this is implemented wouldn't work at all. Let's have another. I mean, now that we are doing the testing, now that I see this, let's have a hash map that maps from integers to strings and try to use that as a mapping. Test mapping complex keys, because that might force us into first of all, we want to write out a scalar in any case. I think we can easily do this. And we would also need to at some point understand that we have to write the entire thing in explicit mapping mode, just because it has complex keys. And I also wonder if explicit mapping mode, which is this thing here, can be mixed with non-explicit mode. So key to value. Oh look, that actually does work. So on a per entry basis, we now have to decide if we want to have complex keys here. So this could be another dict, for instance. Oh. See, but it's only not okay in Python. So if we would say Python tuple and then pass it a map, for the tag YAML, what? Maybe just a single one. Interesting. So Python tags for some reason don't work. Yeah, I think I found that out before as well. So if it's in the automatic failsafe namespace here, then this obviously doesn't work because YAML doesn't define that. But in application space, it should make sense. even though it doesn't. So here we can't even test complex keys, unfortunately. The thing is, this is something that would need to be peaked. So yes, we have to record our current entry. Oh my God, in order to do this correctly. Jesus Christ. And the entry could be arbitrarily complex as well. So we have to record the entire entry until we know what it is, which requires us to have some sort of structure that we can set up with it. Ugh. So for now, I think we could put this onto the list of possible bugs. Because we can't, right now we can't do it. We have to know the value before we actually know it. And this is something we simply can't do right now because of the way this works. Huh? Yeah. So good to know. That test at least verifies that a mixed mode of explicit mapping entries and non-explicit ones works fine. But yeah, we can't know that right now. Mapping complex keys. To do. Oh, actually, mapping complex keys, auto explicit entry. And this is actually a should panic. We are currently unable to enforce using explicit mapping entries for complex keys. This would require us to build a representation of the entire mapping key before we put down any character related to the key value mapping. This requires us to have some sort of YAML value, which we simply don't have right now. Okay, so that's a limitation that I can live with. However, we can test the mapping explicit entry mode. Which we just set here. And the explicit entry mode, this is something that will also, yeah. So what did I want to test? Yeah, two things. Actually, I didn't want to test it. I wanted to make it work. So this thing here just doesn't work because there are quotes around these. Yeah, so these quotes have to go away. And there's even a space here. That's not too bad. I wonder where the space is coming from. Probably the space is added. Yeah, the space is added by the current implementation of Kalin. That we also don't want to see. So yeah, lots of things to look at here. Explicit mapping entry mode. Panic to do. Let's go one after another, right? But this is something we will have to do anyway. So now we have even more failing tests. Awesome. All right. So originally we started getting into this by looking at what happens here in the visit map thingy. So that's the empty case. Otherwise, we just open the mapping, close the mapping, and visit each item. And then this will call visit map element with the key and value. This is what happens here. And then we put the comma or the element separators accordingly, which will do the right thing already. New lines in block mode and commas. Would it do new lines in block mode? Yes, it does. Here we go. Except that it doesn't deal with indentation, but that's okay. And then it serializes the key by its type. And this is just encode scalar for us. So now I think the first thing we want to do is throw in the string here into encode scalar and implement it to the point where plain works. You know, so no folding, no escaping. Not for now, even though escaping is something we really have to look at. Damn it. Yeah, so if we do this now, we need to handle escaping. This is why I didn't use strings before. Then the colon happens, and I don't know if we need, you know, I keep this function for now, but I don't think we actually need it. So we are in prefix mode, so we will not have a suffix that is space. No. This will not happen. Good. And that's the result, fine. So the colon should be fine now. And then the value will be serialized properly already, because right now, for us, this is null. But let's look at the visit str, because that thing now, oh look, escape string. It actually writes stuff. Not anymore. Now we have encode scalar here. And this is basically if value lang greater self opt borrow. Where's the threshold? Small scalar string with threshold. Then we use the small scalar ops, right? So let string ops be one of these. Oh, and we have to clone it anyway. Good. Well, that's fine. Then we will clone it. So that is that. That's small details clone. Scalar details, yes. And the scalar detail is also what encode scalar gets, right? Yes, it gets scalar details. And otherwise, it's supposed to be the big scalar details, blah. So the funny part is that if we are in big string mode, yeah, let's see if this would enforce explicit entry mappings, which is something we can't properly handle yet anyway, but yeah, maybe I shouldn't care. But also I'm kind of interested in knowing. So complex key is value. So that does work. And I think I can have a line break here and it will not work. All right. So in this case, if I have a complex key, complex field, then I already need to, damn it. Oh my, then I would need to have special handling. Then I would need to know already if this is anything special, if it has a space in there, or if it's very long, foo, bar, then all of a sudden encode scalar could start break folding this because it's being told to do so. And, you know, basically visit string should know more about its context so that we can set up a custom scalar string value detail, or basically scalar details instance that will prevent certain things from happening. For instance, if we are in a field mode, right, whereas enum units, so visit string, the variant name, there are limits on what the variant name can be because Rust has limits on that. And yeah, it's just that. So we can basically provide that information to him. Visit enum unit, visit sequence, visit map. Where is it? Visit enum map. So here, wherever we do this, if we have a map element here, yeah, I think what I want to do here is wherever it says visit string, I actually don't want to do special stuff. There I want to call, because we know it's a string, there I want to call encode scalar directly. That's the thing. So this is for us just a string. This is something we consider on the value side. This is only called, let's put it here. This is only called if the string is on the value side, or if it is part of a, oh wait a second, visit string, where's the visit map element? Yeah, so the key can be complex, or if you are part of a complex key of a map, or even if you are not part of a complex key, right? Or if, I mean, basically this can also be called if it's part of a mapping, or if it is part of a generic mapping, like a hash map. This, yeah, damn it. So here this would be the case where we would need a some special handling to do. We should know if we are a key of a map. Yeah, this could also be a complex key, right? This could be part of a complex mapping key, or part of a complex mapping key somehow, because this would force us to kind of pre-generate the value and kind of, I don't know. Yeah. So for now, we just do what we have to do. So that's our options. Fine. Now we can say, well, encode the scalar here. Self encode scalar. We can just pass the value directly there. So it gets a tag string, right? Which is something that will panic. Then we have the string options, which are owned. Then we have the value, which is a borrow. And the return value of this is what we are interested in. And this will now panic. Oh, encode scalar. True. Panic. To do escape handling. If there's something to escape, we must blah, blah, blah. There's a to do, explicit entry mode, std out. True. Don't have that at all. Yeah, so the explicit entry mode, I think this is part of, oh, damn it. Wherever we do any kind of mapping stuff, wherever we use column basically, there we know we do mapping for enum sequence, for enum map, and so on. So you probably want to have something like encode entry. And this encode entry will do the right thing. Yeah. But I think right now we don't even have that. I mean, right now we have no chance to have it just because we are lacking this value handling thing. Oh man. It's kind of weird. Thanks to this handling, thanks to the requirement for being able to peek a value, basically, in a statically typed language, we will, in some sort of mode that is depending on callbacks, we will actually get closer to something that is recommended by the spec, which always says, well, you need some sort of nodes that are the basis for your presentation. So we need to build a graph, and we don't do that right now, just because we don't want to set up own custom data structures here, which cause memory after all, and will require us to do heap allocations and whatnot. So this really is why this gets more, I mean, we finally get to some sort of mode where we sometimes will have to do that. So there are modes which basically, whenever we are not dealing with a actual map, we can just optimize this. So let's do this. Let's do this first. So the map stuff is special, and we actually can't handle this. Yeah, I don't know how many to-dos I should put here. How many more? So we open, and I'm not sure if we actually have to do this, because if this is the first one, we never do anything. Oh look, here we call visit map. For the type itself. Yeah. So for the key, we know what we have. That's good. And it's always the first one. So this call basically is not required. But the optimizer might be able to do it. Yeah. If this is... Yeah, damn it. We don't do this here. On the other hand... Yeah, is there another case where it's hard-coded to true? Just here. I think then we can kick it out. Okay, so here we want to have the scalar thing. And we know that the variant is a simple string. So we treat it that way. We treat it as key. Oh, damn it. I think I remember now. We have a custom setting for key details. And right now, we do not even know that in case of a mapping. Damn it, damn it, damn it. We know the variant is a simple string, so we treat it that way. So that's good. Self encode scalar. There we go. It's tag string, scalar details, self opts borrow, scalar details clone, and the variant itself. That is it. Awesome. There's a baby crying out there, and it's getting on my nerves. It doesn't stop. I think it's this one child here in my neighborhood that always cries all the time. Jesus. Crybabies. So, yeah, here we know the details, and I think I want to note this down here as well. That yeah, because as long as let's put it in this area, as long as we don't know, we actually use the wrong settings. Should be scalar key details, right? Is it called like this? It is. More like that. Man, it's getting more complex by the minute here. Yeah, so this is a problem right now. So that's not handled correctly. Interestingly, in the JSON world, it's also not handled correctly. So for JSON, that doesn't possibly work, but basically for JSON it will work, because we will know here if we are actually writing a key right now. And I think this is some state that we could already have, because this is very specific state. We say, well, key serialize, and this is where we start to do that. We are a key, and here we end to do that. So it's really just a flag that we set here. And wherever we know that it's a simple key, we don't need to do anything special. So where did I start doing that actually? Come on, tell me. Here. So visit enum unit, right? So this is kind of a duplication of, it's kind of a special case. Anyway, and we start with the special case to implement this. Yeah, let's go one after another, right? Let's see if this still builds, because it should possibly do that. Oops, cannot borrow self-ops as immutable because it's also borrowed as mutable. Oh shit, this thing. Scalar key details is a clone. Remember, we did that in plenty of other places. Scalar key details. Borrow, check. Let's put a sad face here as well, because that shouldn't be necessary. That's a known bug. Let's say a known limitation. It's not really a, well, it is limitation slash bug slash annoyance. So why does that not work, please? I can put it like this, and there is a semicolon missing. That is that. Cool. Now it builds, and we can keep moving forward. So this is kind of what we have. Let's search for Cullen. So here we have the same thing. And the moment there is a true here, we don't need it. Did I also change it here? Yeah, I did. Cullen, and enum map. Enum map. Okay, sorry. So here again, if it's true, we do not do anything, just like that. Voila. It's always called the same, fortunately. Oops. Cullen. And now the map element. So here is where we have to mark somehow that we are serializing a key. It is mapping key. It's just a flag for us. Is mapping key. If true, we signal that all values serialized while true, signal that all serialized values are going to be part of a mapping key. If the key is not simple enough, the mapping style may be forced to be either an explicit mapping entry if key is complex, or to use non-plain flow mode as escapes might be needed. Yeah, so this is one way to handle this. Let's initialize it with 0, with false, is mapping key. And now when we serialize the key, then we want to set this to true. And now that we are done, you want to set it to false again. So now we can at least know what's going on. And I think I want to panic until this is implemented. So visit, basically whenever a value is handled, we need to check for this. This is the thing. I think I might want to add this everywhere now. Yeah, because that totally affects us. So we will check very soon if this builds as well. So if self is mapping key, so only in the else case we can do what we usually do, like this. Panic to do mapping values complex mapping entries. Complex mapping keys. Complex keys. Let's call it complex keys. Good. So that is, now we actually use it. I leave the to do here, but it's kind of something we might want to add anywhere, or which kind of applies anywhere anyway. Gee. So yeah, that still fails nicely. I just want to be sure I don't add use serd. See, now it doesn't need it anymore. What the heck? It only needs it when building. Okay, so maybe there's a way to smartly ignore this depending on compile time configuration. For now, I'm definitely not. I have no idea how to do this, because if I remove it and I want to rebuild the file, then it will be missing. Right? This is what we learned previously. We are 42 minutes in. I think I will just add this part here, because it's something we now need everywhere. Let's just build stuff now. Oops. And we will adjust this later accordingly. This is something we need. And the cool thing is that this will only be relevant. Yeah, I think this will only be relevant for hash maps. For fields of any kind, this will never be relevant. So we can already do quite a lot of stuff here with the simple things that we will now have to implement. Yeah. If it looks repetitive, then I can tell you it is. I wonder, could we have a macro for this? Or a function? You know what? Let's undo this. Because I think we can have a generic function for this. Totally. But it needs to be on ourselves, because we might have to adjust our own state. Yeah, let's try it. Let's not do this. Let's not try to be too stupid. I always feel guilty if I copy paste stuff like this, for good reason. Even though it's kind of there already, which kind of makes it easier for me to do this. So here, this is the only case where we might want to implement this manually, partially at least. I think in these cases, I would rather want to have a utility function. Fn visit any of type t, where t has display, right? Look at that. So here we have special handling for these, for floating points. Okay. Yeah, so we kind of need two different versions of this. But we could have two implementations as well. Any t mod self. We pass on the value, we own it, right? We just pass it, or it's made by copy. Value t, returning NIO results. Where t is display. This is the only thing we need. Yeah. And this formatting is special, and apparently there is no other way to do this. But anyway, let's see how that goes. So now I can do the same thing. Here I can generalize this. Let's say self write any. Let's try it here. Write any. We just put down the value here, and that is that. Let's see if that works. Method visit any is not a member of self serializer. Undeclared type name FMT display. Maybe this is why it didn't exist. Use std fmt. Let's use fmt display, where t is display. So maybe this works now. Really? I just wanted to say maybe it doesn't like generic types here. But actually, oh no, wait. This is our own one. So what we actually want to do is put this into the block up here, right? Here we have our custom functions. No, wait. This is still the wrong one. Up here we have our custom stuff, which is not part of the trade, right? There's a problem here. All right. Visit any. Now it should be there and it should work. First and foremost. Write any. Where did I put this? Write any. Visit any. So in any case, I did it wrong. Now we have a chance to make it work. It could work now. And the good thing is that now we can deduplicate all of this stuff and save a lot of code later, or hassle later. And this is really, that's a good thing, because we deduplicate here. That's fine. That's fine. Look, visit bool. So here we need to handle these cases, right? And this special case we might also put into some separate method or function to handle it. Right now we have no code that would do that, so I think it's good enough to just mark it like so. Else and oops, if value, I think that's what we had here. Yes, so that's what we should see here. And of course, it's not right, true, or false, but we have to obey to the standard here, which shall be encode scalar. Do we use, by the way, the write any currently doesn't obey anyway. This must be using encode scalar. Okay, it should build nonetheless. And I think now we get into trouble just because encode scalar requires some more details, some more information that we do not provide right now. We deduplicated it, yes, awesome. But we need a tag. And I think the only thing we are interested in is... Oh, damn it. No, we need a real tag. The tag is only kind of required. I mean, as you can see, the only thing we are looking at is if tag is a string. But we still need to have proper tag values. Yeah. To be able to serialize the tag if we have to serialize the tag. This is why we need to do this. Yeah, that's the only reason. Yeah, this is the part. Okay, I guess I have to do it now. And we need the scalar details. And the scalar details, they're always the scalar value here. Okay, so write any needs a value, needs ops, scalar details. So now this shouldn't build anymore. And now that I'm at it, I can as well put the tag. And we might put it in the right order. So we have options here. And the tag is a tag here. And this is that. And now we should be able to just call self-encode scalar with tag, ops, and the value. Like this. This should work, but now it will tell us that we can't call it like that because we don't have all the parameters. Yes. 306, what? Oh. Asref string is not implemented for type T. Oh, true. Because actually we want asref. Asref string, and we want... Yeah. This is what we want to say here. Asref str. Ooh. Now we have another problem. Because all these types that we have there, they don't even implement it. So we need some sort of buffer that we also don't have. Ugh. So we could work around this and use format, but this is of course something that I'd hate to do. Yeah, so lots of work to be done here. The good thing is for all these simple cases, oh man, it will be the same. All right. This was just right before. I could keep it that way. I'm kind of getting ahead of myself, you know? If I just keep it that way, then at least it would work. Even though we would get the encoding totally wrong. Yeah, let's keep it that way. And let's just say to do st use encode scalar, which requires us to provide a value that is already... Oh, you know what? We could take a value that supports display here, and then yeah, we could do that. We could for now use the slow implementation, which will just work. It returns a new string like this. I think this has asref str. Let's see. See, this will work now. And this way we keep it really easy and only have to, yeah, so to do, use pre-allocated buffer, like a formatter that writes into the same string. Yeah, the cool thing is this handling we can do here, and we do it just once. That's awesome. So for now we have the slow implementation. Have the slow but easy implementation. For now. Awesome. That is that. So now you just have to review all of this and see what kind of tags YAML supports by default. The YAML.org here, this is the namespace somewhere, right? YAML string, interesting. Tag directive, yeah, we don't support that right now. Where's the style? Where's the YAML? I think it might even be here. Oops. Oops. Tag. Yeah, maybe YAML.org will give us what we need. Spec issues. Reference parser. Yeah, that thing is offline. Nice. That really shows, huh? That shouldn't be. Totally not. YAML issues. Hey, cool. It's on GitHub. Let's make a quick... Then I will be happy to make a quick bug. Maybe there is a YAML site as well. YAML.com. What? Project home. YAML DE? What? German? Really? Ah, the CSS framework is German. Interesting. PyYAML, YAML.org website. Probably there is this issue would better be here, huh? Seems down. See subject. And I will make it even better and say, well, look at this. Look what I get. Voila. This is how that looks like for me. And I might, just for the purpose of the demonstration, make this a bit smaller. Like so. Voila. The link is found on YAML.org. Was found is shown on yaml.org. Okay, let's quickly drop the screenshot. What kind of screenshot is this? Huh. Yeah, accidents, I guess. So here we go. Good. That is that. Cool, I did something hopefully useful. And this is this. What did I actually want to do? I wanted to actually find the spec, the style stuff. Or the tags, the tag namespace. Tag, available tags. I've seen a complete listing, or I've seen a URL once that showed where the styles are supposed to be listed, the tags are supposed to be listed. But I don't find it anymore, obviously. I thought it was something like style. No, it was not. Why would it be? Maybe here. No, that's just a spec. Damn it. We are 1 hour in. It's a long one. And maybe I should just terminate it here. Here's these built-in ones. And I need to know, okay, probably a few examples. I think this is the ones, right? Ah. Is it that? JSON schema, tag resolution, repository. I think this is it, huh? Yeah. Tag map. Oh, we also have to implement the tagging for complex types, for structure types, failsafe schema. I think this is what I was looking for. Here we go. Oh man. Yes, so does this still work? It does. And what do we have? Yeah, I think I will do this in the next session. And I think I shouldn't commit this. So thanks for watching and have a great day.